Welcome back to The Explainer. Today we are diving headfirst into a multi-layered, century-old mystery. Think about it. Why does a tiny, tantalizing gap separating two major continents remain completely unbridged? It's a massive puzzle, and we're going to break it all down. To really put this geographical puzzle into perspective, the Strait of Gibraltar, that stretch separating Spain and Europe from Morocco and Africa, is just 14 kilometers wide. Literally. That's a distance you could theoretically drive in under 30 minutes if there was a road. I mean, you can stand at a scenic viewpoint in Spain and clearly see Mount Jebel Musa in Morocco with your own two eyes. So why on earth can't we just hop in a car and drive from Europe to Africa? Well, let's look at the sheer economic magnitude of this choke point because it's honestly mind-blowing. We aren't just talking about a convenient shortcut for tourists here. Every single year, roughly 100,000 ships and 18,000 oil tankers squeeze through this tiny gap. It facilitates a third of the world's global oil and gas and an absolutely incredible 50% of all global trade. Think about that. Half of the global goods you buy, from your electronics to your clothes and food, likely rely on this incredibly narrow stretch of water. It also handles a staggering 80% of the European Union's merchandise trade. The global economy is heavily dependent on it. To solve the mystery of why this incredibly valuable shortcut remains unconnected, we're going to peel back the layers one by one. We'll look at the 14-kilometer illusion, a century of impossible dreams, nature's invisible defenses, the 28-kilometer solution, and finally, the geopolitical roadblock. Let's start with part one, the 14-kilometer illusion. Seriously, why hasn't this been built yet? Think about what humanity has already accomplished. We have conquered far greater distances and way more impossible terrains in record time. We built the massive Hong Kong-Zhuhai-Macau Bridge in just 9 years. We dug the 50-kilometer Channel Tunnel between the UK and France in a mere 6 years. We even dropped 11 billion euros boring the 57-kilometer Gotthard Base Tunnel straight through the solid rock of the Swiss Alps. Yet, somehow, every brilliant engineering mind seems to hit an absolute dead end at the Strait of Gibraltar. Which brings us to part two, a century of impossible dreams and the wild history of ambitious engineering here. Because, it certainly isn't for a lack of trying. From a German architect's incredibly grand vision back in 1920, all the way to a formal diplomatic agreement in 1979 between the kings of Spain and Morocco, which, by the way, actually formed dedicated public companies to research this. The timeline of ambition spans generations. It really shows this continuous, unrelenting effort over decades to conquer this stubborn stretch of water. And some of these past ideas were just mind-boggling in their scale. Back in 1920, Hermann Sergel proposed Project Atlantropa. This was a plan to build a massive hydroelectric dam, literally drain the Mediterranean Sea by 660 feet to reclaim land and connect the continents. It would have required 7 huge dams and lock chambers, similar to the Panama Canal. Unsurprisingly, it failed due to unbelievable costs and obvious environmental concerns. Fast forward to the 1990s, an American architect, Eugene Suey, proposed a $10 billion floating bridge. But this wasn't just a bridge. It involved a 2-mile underwater tunnel emerging into a 3-mile floating artificial city right in the middle of the sea, complete with a 23-story building, windmills, and waterfalls. Its structure was designed like a flexible fish spine, tied down by triple cables so it could actually move with the water. Crazy, right? But moving on to part three, nature's invisible defenses. This is where we hit the geographical and geological nightmare. See, all that human ambition repeatedly crashed into an invisible villain, a scientific phenomenon known as upwelling. The strait is essentially a choke point where the warm, less dense water of the Mediterranean aggressively collides with the cold, dense water of the Atlantic Ocean. The warm water rises up, the cold water sinks down, creating these violent convection currents. Add in high wind speeds, and the water is basically filled with invisible water tornadoes. The surface currents out there race at a minimum of 11 kilometers per hour. To give you an idea of the sheer violence of these waters, during a 1991 survey by the ship Nautilus, the currents were so strong the research ship couldn't even drop anchors stably, and their drilling equipment literally snapped in half. And beyond the crazy currents, there is the extreme vertical drop. The data shows exactly why past successes just don't apply here. The shortest 14-kilometer path is known as the canyon route, but its depth plunges between 800 and 900 meters. Compare that to the English Channel at just 180 meters, or the deepest subsea road tunnel in Norway at 292 meters. Bridging the 14-kilometer canyon route would require underwater pillars as tall as 3 Eiffel Towers stacked on top of one another. Oh, and you still need to leave 70 meters of clearance above the water so you don't block the world's most critical shipping lane. To make matters incredibly worse, the deep seabed isn't even solid rock. It's filled with breccia and clay. In lithology, breccia is basically considered the weakest material out there, a highly porous soft mixture of clay, stone splinters, and small rock blocks. It's essentially like trying to build a skyscraper on wet mud. If you actually tried to plant a massive concrete pillar as tall as 3 Eiffel Towers into this stuff, the soil would immediately give way, and the bridge would instantly collapse. Furthermore, building here means building directly on top of a major tectonic fault line. This is the exact friction point where the giant African and Eurasian tectonic plates constantly grind against each other. It's an active seismic zone, the exact same one responsible for the infamous 1755 Lisbon earthquake that claimed roughly 60,000 lives. So imagine a bridge with some pillars anchored in the Eurasian plate and others in the African plate. Even mild tremors would scatter the whole thing like a house of cards. Okay, let's pivot to part 4, the 28-kilometer solution and the quest to find a new path. Faced with water tornadoes, unbuildable depths, crumbling soil, and active earthquakes, engineers had to completely rethink their approach. And here is the plot twist. By abandoning that tantalizing 14-kilometer canyon route for the much longer 28-kilometer threshold route, engineers finally found some hope. Historical ocean floor discoveries back in 2005 revealed that this longer route was vastly shallower. We're talking only 300 meters deep instead of 900. Plus, the layer of dangerous soft clay was much thinner here. So, with this new data, the strategy totally shifted. They completely abandoned the bridge concept in favor of an underwater tunnel. In 2006, a Swiss engineering firm actually won the contract to finally connect the continents using 3 underwater tunnels, 2 for high-speed rail tracks and a central one for service. This project promised a massive boom in trade and travel, literally cutting the journey from Casablanca to Madrid from 12 hours down to just 5.5 hours. Work was officially slated to begin in 2008. But then, we hit part 5, the geopolitical roadblock, or as I like to call it, the final human barrier. The engineering plan was basically perfect, the science was sound, and the funding models were ready. But just as the drills were preparing to spin, they hit the ultimate roadblock. Decades-old territorial disputes have repeatedly brought this brilliant engineering project to a complete standstill. The territories of Ceuta and Melilla sit directly on the Moroccan border near the strait, but they're controlled by Spain, a holdover from colonial times. In 2008, the Spanish king visited these territories. In retaliation, Morocco pulled its ambassador, and the tunnel project was instantly paused. Then, later in 2020, Spain allowed a rebel leader from Western Sahara to receive medical treatment in their country. Morocco viewed this as support for a rebellion, and once again, diplomatic ties frayed, stalling the project indefinitely. Today, this isn't just a local issue between 2 countries. Major global powers, including the USA, UK, China, India, and the EU, are heavily pressuring both nations to put aside their historical differences. Why? Because as we discussed earlier, leaving such a critical global trade choke point vulnerable is a massive economic risk for everyone. A stalled route that handles half of all global trade threatens global economic stability. The world urgently needs an alternate link here, which leaves us with this final, fascinating question to ponder. We have the technology to conquer the extreme depths, the brutal ocean currents, and the crumbling earth. But despite conquering the sheer forces of nature, must humanity first learn to build a bridge of trust before we can lay a single brick of steel? It's a powerful reminder that sometimes our greatest engineering challenges are completely outmatched by our diplomatic ones. Thanks for joining me on this explainer, and I'll catch you in the next one.